this wall becomes unstable, right? And due to that unstableness and due to extreme, normally what's going to cause this is high levels of hypertension, high blood pressure. What's going to happen is you're going to get a balloon, right? And so all this flow of blood that's coming through has weakened this arterial wall. And instead of blood doing nice, good things and going down this way, that's become so weak that your hydrostatic pressure inside of your vessel is causing it to then go up and divert this way, which then fills this. Now, this is an aneurysm. The ballooning is the straight definition of what an aneurysm is. What happens afterwards, whenever you have your blood vessel, right? And that balloon then bursts, is a rupture. Boom. This is your rupture. Your aneurysm is the ballooning, and the bursting is your rupture, right? So if you get a question on the test that says, as a competent EMT, you understand the definition of an aneurysm to be, and then there's question A, that's a ballooning of the blood vessel. Question B, that's the rupture of a blood vessel. And your answer C, that's the ballooning and eventual rupture of your blood vessel. Correct answer is going to be C because it's the most right. Because aneurysms include both the ballooning and the rupture, right? And so that's the big thing with aneurysms, is understanding that your actual aneurysm does not necessarily include the rupture. It describes the ballooning of the blood vessel, right? Dissections are just a wee bit different. So each blood vessel that you have has your outer wall, and then you have an inner lining, right? And your blood flows through here. What happens in a dissection is, instead of with an aneurysm where you have a weak point and it balloons out, you have a weak point or an onset of trauma that causes a rupture in the inside lining of your blood vessel. So instead of ballooning out, because this is still intact, what happens is you have the blood flow then goes here and eventually causes this to expand out and fill with blood. These are rough. This, and when you're coming into signs and symptoms, your rupture or your aneurysm is going to feel kind of stabby, right? It's a quick burst. Get stabbed, quick shot, it's going to hurt like a stab. Your dissections, because of it flowing through here and it continuing to build up pressure inside these separate membranes of your blood vessel, you're going to feel a tearing, a ripping. Right? When it comes to aneurysms, your biggest issue is that you're having a leakage of hemorrhage out into the body, or whatever space it's going into. With your dissections, the biggest issue is the fact that you're increasing your container. So instead of having just this little line to go through, you're increasing the size of your container, because then blood is going in between here, which is what causes your drop in BP here.
Would dissection cause would it cause an obstruction?
Not necessarily, no. So it can if it's small enough for your body to patch itself. Theoretically.
Okay.
All right, don't take that as science because Micah is not 100% sure. But theoretically, yes, you could have clotting agents come up and fix this,
That's it.
and then get nicked with the fibrogen and cause more scarring and more platelets to come through, creating a thrombus. That can't happen. At least in my head, the way I think it might.
Mm-hmm.
For here, your stabby pain, and then you're dropping BP is going to be a little bit more significant because you're going to have more of an area of volume for that blood to leak out to, right? Where here, you're still maintaining that pressure inside of that vessel, and your container hasn't enlarged that much, so it's not going to be a significant drop in BP, right? Like you remember